What's up, guys? Hey, Devs here, and another day of LeetCode. So, I'm gonna preface this by talking about yesterday's video. I posted yesterday's video, or I set it to publish last night around it's like 11:40, 11:50, about what time it is now. So this one will actually be posted tomorrow, but it'll be at like 12:30 in the morning, something like that. But I went to post it last night, and I put my computer in sleep mode so I could put the puppy to bed, and there'd be no lights on my computer. Well, when I did that, it stopped the uploading process. I went to school, got home, and it didn't upload until like 3 hours ago. Not three, like four hours ago, I guess, 5 hours ago. So I did post the video, but it just didn't post till today. So today I'm just gonna jump right into this problem. It's the number 27, remove element. I give an integer array nums and an integer value. Remove all occurrences of value in nums in place. The order of the elements may be changed. Then return the number of elements in nums which are not equal to val. Consider the number of elements in nums which are not equal to val be k. To get accepted, you need to do the following. Yada yada blah blah. We're given the integer 3, 2, 2, 3. Then let's remove value 3 and then move the 2's to the front. So that one's fairly simple. And these last two values can be anything, preferably 3. And then nums, this one's equal to 0, 1, 2, 2, 3, 0, 4, 2. They want us to remove the element 2. There's 2's here and here. So what I'm thinking is I looked at a little bit of the 2-pointer problems, but I haven't worked with any really. So I think this is a 2-pointers problem. So we'll have an index keeping track of the last and an index keeping track of the first. And then we'll break out once. We'll call this just L for last. And then we'll just call this I for index because this is the current index. Once L is less than I, we'll want to break out of this, right? So that means that they have passed each other and there's no more work to do. So we'll want to increment L if L is equal to the value, or the value at L. So we'll go ahead and increment that one by 1. And then if I equals, if I doesn't equal 2, we'll increment that one. And then if I equals, it doesn't equal 2, we'll increment that one. And then if I is equal to 2, then we'll want to swap these. So we'll put 4 here and put 2 here. Or we don't really have to swap them. We can just leave 4 there. And then we'll increment L after the operation. And then we'll move I as well. And then we'll swap these two because this one's equal to 2. And then we'll put 0 here. And then we'll increment both of them. And then in the event that they equal each other, or greater than or equal to, then we'll break out, right? And the pointers point at the same spot right here, and the rest of the values don't matter. So we'll go ahead and break out of the loop. That's kind of like what I'm thinking. And then it wants us to return how many times 2 has occurred in the list. So we'll keep up with the amount of 2's we encounter, and then we'll create a int I equal to 0, and then int j, or we'll call it last. And we'll set that equal to nums.length -1, because one point to the last element. And then we'll do while I is greater than or less than last. Okay. And that's when we want to loop through. And then we'll run our return our remove count right here. And for each iteration, we want to check if last dot value, the nums at last, if that is equal to value, Then we'll want to do last minus minus and set rem count plus plus. So this operation is our moving our last pointer. So last is here. Since it's 2, we removed it, or we basically removed it. It's at the last element, and then we incremented the remove pointer to the next. And then I is still here, and we still want it to be here. Okay. And then if that's that, then else will do everything else that we want to do in the function. Because that will just be one iteration loop. And then else we want to check if this value is equal to the num, right? So we'll do if nums of I is equal to value, then we'll want to set nums of I equal to nums of last. For last, it was the last, but it's the last of the k. Where's the k? Of k elements, that would be the elements that we care about. So k is 2 in this scenario, and then k is 5. Oh, so okay, we still got to keep up with remove count, but we're not keeping up with the amount we remove. We want to do nums dot length minus the remove count. And then once we swap the values around, we'll want to do remove count plus plus because we removed one. And we can go ahead and set I plus plus and what's it? Set j plus plus. Not j, last plus plus. And then no matter what, if we go in this if loop, we want to increment I. And I think that's all the logic we have to do for this one. So we can run it and see if it works. If I forgot a semicolon or, yeah, there, it got us. It always gets us. And then I plus plus, it also got us there. Then we got the semicolons in every other part. Ooh, wrong. All right, so we return value 3, output 2, expected 2, 2. If we go, hmm. Oh, that would be a fatal flaw. We are decrementing last, not incrementing last. Yeah, okay, so that worked for those two cases, and for this case, and if we submit this, this should work for every one. Wrong. Expected that. That should work, right? So if move count equals 0, I equals 0, last is equal to nums dot length. If we put the equal to in there, would it work that way? Or does it fail something else? No, it worked. Okay. So what happened there was I is set to 0, and then if there's one element in the list, then last is automatically set to 0 because nums.length is 1, 1 minus 1 is 0. So it would never break into this while loop, therefore never incrementing the remove count. And then nums.length minus remove count never increments. At 0 milliseconds beats 100%. So this is one of the 2-pointer problems, and we'll kind of walk through the more complicated one we use in our algorithm. So we have the remove count, and we have I, and we have the last. So I'm just going to keep remove count over here, remove count, and then I is equal to the first element, and then last is equal to this element. So the first thing we do while they don't pass each other, right? As soon as they pass each other, we know we have found every element in the list. While they haven't passed each other, we'll go ahead and check if num's last is equal to value, which it is. So we don't want to swap our last number, because all we're doing in the while loop, if it doesn't, if nums of I is equal to the value, so that would mean that, like in this scenario 2, if I is pointing at 2, we want to swap it with a value over here. Or not swap it, we want to set it to a value on the right-hand side. And we don't want to set that value to 2 again, because that kind of defeats the purpose. So the first thing we're going to check is we're going to make sure last is at a valid element to swap. And so L at 2 isn't a valid element, so we'll go ahead and increment L by 1, and then increment the remove counter to 1, because we encountered one element that was 2. And all remove counter does is it's going to end up counting every single value that equals value inside that array, right? So at the end, remove counter should be 3. And so we'll go through the while loop again, because all we did was for the first iteration it was we decremented the last pointer, and then we incremented the count. So then we'll go in one more time. I is not less than last, less than or equal to. Last does not equal the value, so we'll go to the else statement, and the else statement checks if I is equal to value, and it isn't, so then it just increments I by 1. So now we have I pointing to 1 and L pointing to 4, and then once again I is not less than or equal to last. Last is not equal to the value that we're trying to remove, so and I's value is not equal to the value we want to remove. So we'll increment I one more time. Once again, last is not equal to the value, and then we check if so we go in the else block right here, and we check this statement right here. If the nums at I, which is 2, is equal to the value we want to remove, which is also 2, we'll do this block of code, which we will in this iteration. So nums of I is equal to nums of last. So all we're doing here is we're setting this 2 to a 4. And then we're not setting 4 equal to 2, because this value isn't even going to matter in the grand scheme of things. So it saves us an operation, and it saves us a little bit of time. So then in that scenario, we know that this value has been already accounted for, so we want to decrement last. So every time we encounter a 2, we want to decrement last, and every iteration we want to be sure to increment I, unless last points at a 2. So in this scenario, we have the 4 there. Last now points to 0, and then I also gets incremented, so I is now pointing to this 2. We'll check if last is 2, or we make sure I is less than or equal to last, which it is. And then we make sure the numbers at the last spot is equal to the value. It's not, so we go to the else block. And the else block says if the nums at I is equal to value, which it is, because it's 2, we'll go ahead and set nums of I equal to nums of last. So last is pointing at 0, and I is pointing at 2. So we're just going to overwrite the 2 and put a 0 in here. And then from there, we want to decrement last. And then, oh, I almost forgot. So we did 2 swaps. We found 2 2s. So our count over here would now be 3. Almost forgot that part. And then after we break out the if statement, we'll go ahead and increment I as well, and they point to the same value. And then if I and L, if it's equal to the value we want to remove, we'll go ahead and set last equal to minus minus, which in this scenario it doesn't, and then we'll set the remove count to +1, but in this scenario it isn't. So all we do here is we last is not pointing to 2, so we go to the else block. I is also not pointing to 2, so we go ahead and just increment I by 1, and then we'll go ahead and put I here. And if you see now, I is not less than or equal to last. I is actually greater than last. So we'll break out of the while loop, and it wants us to return the size of our list now. So if you iterate with the number that, if we set I equal to 0 and then I is less than or equal to the number this returns, then it will only iterate through the first of elements that isn't 2, right? And order doesn't matter, so we didn't have to keep up with order at all. Yeah, that's all the solution. I think it's a simple two-pointer problem. I was looking at another one that's a bit more complicated, even though this is oh, it's an easy. I thought it was a medium. But yeah, that's my solution. It runs in 0 milliseconds. This is an O of n time complexity, I think. It's probably like n divided by 2 because 2 point, well, yeah, it's an O of n time complexity and it's a space of n. It's an O of n space complexity. Because the only 3 variables we initialize are these 3. We only call the function once, and the only things in the heap are int array and then our which this is just a reference variable, so the int array is already created. The int value is passed by value, so we create a new integer here, and so in total we create 4 integers. There's one function call which is initially called, and then worst case scenario we'll run 1 block of code per value in the array, and then we return the nums dot length. Runs in 0 milliseconds, so this was a good solution. It beats 100%. And yeah, so if you have any questions, comments, or concerns, please let me know. It is now day 24, so I'll get y'all a video tomorrow morning sometime. I have the therapy at school. Me and my girlfriend, we got to run to the store, and then I have work tomorrow night, and then after work we have a Halloween party to go to. So a busy Halloween night. Well, actually it's Halloween right now, so happy Halloween to anyone that's watching this. Like I said, if you have any questions, any comments, go ahead and leave them down below. I'll try to get back to you. I haven't been getting back to many of the comments here recently just because I've been pretty busy with work, but I'm going to try to get back on that. It should clear up a little bit this next week. I do have a few assignments due Monday. My rough draft was due today. I was working on that all day. That's why I didn't get on this problem until 11:30, 11:40. Next Tuesday I have another test. But in between then, I should be able to do some harder problems. I have been doing easy problems the past few days. Kind of feel bad for that. But it's more about doing it every day than doing hard problems. We're expanding our mind. We're getting the work ethic in there. And I have been staying true to my word and doing a LeetCode problem every day. So this is day 24, I think now. And so I'm going to end it here. Y'all stay healthy. Y'all stay blessed. Y'all keep coding. And I will catch you on the next video. Hey Devs is out. If I can get my mouse over here.